In this video, we will talk about the essence of a function in general, as well as in terms of programming. While we presume that you already have some knowledge of mathematics and programming, you are welcome to comment if anything is unclear to you. If you look for a definition of a function on Wikipedia, you will find something like a correspondence between elements of two sets where every element of the first set is associated with the element of the second. I'm sure it would be hard for a newcomer to wrap their head around this definition, let alone visualizing and memorizing it. A function is essentially a construct that stores the dependence of one quantity on another. Alternatively, we can say that it receives something at the input and returns it at the output in accordance with a certain rule. It can be a number, an array, a text, an image, a sound, or almost any other entity that depends on the task and on the function itself. The function can be represented as a graph or as a data table. Hence, a graph may be converted into a table, and vice versa, a table can be displayed as a graph. Still, the most convenient and compact way to store a function is through a formula. By the way, a neural network is a type of function as well, or rather its approximator, which can receive certain information on the input and output it as a data shaped the way we need it to be. Again, that's up to how we set the neural network up and train it. So let's start with a simple example with numbers. Let's make a simple linearly dependent function. We will create a linear function. Then we'll add two arrays for storing the input and the output data. One array will be filled with the input data ranged from -10 to 11 with an increment of 1, while the other array will contain the output data. This function returns the same data on the output that was received on the input with no changes. This is direct dependency. If you look at the visual result, you will see a diagonal straight line, which in fact is representation of its name, linear. The line itself is called the graph of a function. In our case, we only see the points of it, but if more data was obtained on the input, it would make a line. Now let's make the function a little more complicated and let it be nonlinear. We will create a nonlinear function. Then once again we'll add two arrays for storing the input and the output data, and fill both arrays with the input and the output data respectively. The S-shaped curve of this function defines its name, a sigmoid. Some refer to it as the main curve of the universe. We'll return to this topic when we study neural networks. As you can see, there is no hidden magic, and as you may have already guessed, it's possible to build any function with any type of values and data processing. You can also control the amount of values you include in the function, use one function inside the other, or even build complex chains of them. Another interesting point is that if we measure the rate at which the value changes at function's output, we will be looking at another function to describe that rate. When a function produces another function, the second one will be called derivative. Such functions will be helpful to us further on. The derivative shows how the output value of the parent function changes when the new data enters the input. The further the value is from 0 in the derivative, the steeper the rise or the descent is in the main function. And the shorter gap we take, the more accurate the derivative will be. By the way, the function that creates the derivative is called the primitive function. A derivative, for example, will make it possible to explain the neural network where it made a mistake while making decisions, and what changes in parameters it needs to make in order to yield more accurate predictions. But it is not the only way to take advantage of a derivative. Let's see what it looks like. One more time, we'll add two arrays for storing the input and the output data. Then fill one array with the input data and the other with the output data respectively. We will insert the body of the primitive function and the input data into the derivative. It's important to know that in this case we use the ready-made function from SciPy library, which is imported at the very beginning. In this case, you see a constant value because as primitive function increases at a constant rate, we observe the same value in the derivative. Therefore, the derivative here shows us that each increment changes the function by 1 unit. Let's once again arrange two arrays for storing the input and the output data, and as before, fill the arrays with the input and the output data. In this case, we will insert not only the body of the primitive function and the input data into the derivative, but also the interval to measure the change in the first function. As you can see, the steeper the curve of the primitive function, the greater the value of the derivative, and vice versa. It's important to know that depending on the function, you may find the derivative without including an additional library. For example, a sigmoid derivative will look like this. It is common to put a prime mark ahead of formula's definition for derivative functions. But we took a shortcut here. In case you want to deep dive into this, you may look for a table of derivatives online. How and why does it work? Let's analyze the geometric meaning of the derivative. First, you need to build a tangent to the graph of the function. To do this, you need to select 2 points on the graph with a relatively small distance between them, so the tangent doesn't turn out as a second line. In this case, we will use the increment of 1/10 for the clarity. The tangent of this tangent's angle of inclination will be equal to the derivative. If the value of the derivative is negative, the graph decreases. It might be quite challenging to grasp what's going on right away, so this is the perfect moment to pause the video, rewind, and go over the material once more. As you can see, no magic is involved. So now you know what linear and non-linear functions are. You also know what a derivative is, how you can find it, and why it works. All these elements will be your keys to discover the world of machine learning and artificial intelligence. If you like this video and want the channel to keep on going, press like, subscribe, and share with friends. Thank you!